Welcome to this presentation on applying data analytics to urban water consumption. In this presentation, we'll be discussing the issues that cities face relating to water consumption and water wastage, and the analytical methods that we can use to alleviate some of those problems. Water pipe leakages often prevent cities from efficiently and sustainably managing their water systems. For example, an average household in the US can waste 10,000 gallons of water per year just through leaks. These types of leaks waste water, energy, and cause unnecessary expense. It's also difficult to detect these leaks by traditional methods. Additionally, external pressures on water systems like population growth and climate change can cause even more variation in urban water demand. This makes strategic planning and efficiently meeting water demand difficult for cities. In this project, our objectives will be to predict water consumption, detect abnormalities in water consumption, and estimate potential water reduction due to anomaly detection.
For predicting water consumption of New York City over a 7-year period, we applied a correlation matrix analysis between attributes and our target variable to assess which of these attributes best predict our target variable. The target variable in our case is water consumption of New York City, and the attributes we're going to use are demographic, temperature, humidity, and precipitation. The demographic itself takes into account both population and income of specific areas of New York City. The temperature range could relate to the consumption correlation, for example, warm days versus cold days. The humidity indicates if the environment is dry or humid, and the precipitation relates to the amount of rainfall in specific areas. For detecting any abnormalities in the water consumption system, we apply anomaly detection approaches such as clustering techniques in order to remove outliers from the model. We then create classification models using KNN and decision tree for prediction of water consumption, as these models are robust against missing data. We then make comparison between these classifiers and we propose our best model, and we apply created model to Montreal dataset if available by city in order to predict water consumption.
Well, the third objective will be the likely savings in water waste and cost reduction due to anomalies detection. To address this objective, we first try to identify strong abnormalities in the case that actual water consumption classes are different from the predicted classes. Then we calculate the differences between observed values and predictive model outcomes for detected anomalies in order to estimate the water amount that could have been saved. Then we determine the cost pertaining to wasted water using New York City water rates. The next step will be to apply model to Montreal dataset, actually, based on the demographic available in New York City dataset. To do so, the yearly average of water wastage per capita for each building is calculated and attributed to Montreal demographic. Then using the predictive models, the amount of water that could be saved in Montreal is going to be estimated.
Moving along to our data sets, the first main data set that we'll be working with is the New York City water consumption from 2013 to 2020. In this data set, it has information pertaining to the consumption data per borough as well as per building. And the graph on the bottom is a small representation of the water consumption trends in the greater New York City area. The table on the right shows an example of what we'd find in this data set, including information on the attributes, the type, the description, and an example. Our second main data set that we'll be working with is the weather data in New York City from 2013 to 2020. So this includes information on the precipitation as well as temperature ranges and the relative humidity. The last data set that we'll be working with is the demographic according to New York City. So this will include the population and the income. So for our remaining steps, following the CRISP-DM methodology, we have an understanding of the context, we understand the data, and now we're in the midst of preparing the data. So this means removing the inconsistencies and finding the most important attributes for the analysis. We will then move on to a correlation analysis and modeling. So we will apply KNN and a decision tree to our data set. Then we will evaluate the models and make comparisons using classification metrics. And finally, we will try to find a way to relate this data to Montreal to see how they can benefit from it. Thank you very much.